Good morning, students. Here today I will summarize the different kind of Friedal reactions. As you know, we have done the Friedal reaction in benzene, chlorobenzene, phenol and with ether. All the reactions are taking place absolutely in the same way. Here I will start the Friedal with the benzene. First of all, I want to classify the Friedal reaction as it may be of first type may be chlorination, Friedal chlorination reaction. So, how the reaction will take place? We know all the aromatic compounds gives electrophilic substitution reaction. So this is also one kind of electrophilic substitution reaction. When we will treat it with Cl2 in presence of anhydrous AlCl3, what will happen? In simpler way, if you will see, it will lose HCl. As a result, the chlorobenzene is formed. Chlorobenzene is formed. Benzene and chlorine with anhydrous AlCl3. HCl is formed along with chlorobenzene. Now, here I want to discuss why anhydrous AlCl3 is used. You see, if AlCl3 have some water, then what will happen? AlCl3 will react with water and it forms aluminium hydroxide and HCl gas. That means AlCl3 will not be present in the reaction and the electrophile will not generate, as the work of AlCl3 is to generate electrophile. Electrophile will be generated by the help of anhydrous AlCl3. If you will take hydrous AlCl3, AlCl3 will hydrolyze into aluminium hydroxide and HCl gas. If you will see the mechanism of the reaction, it is very important. So I am taking this reaction separately. It may be asked by name, it may be in the form of mechanism, or it may be in the form of conversions. It may be that only 1 mark question may be asked. What will happen? We all know Cl2 is non-polar and in normal condition it goes in homolytic fission, but our requirement is to generate the electrophile. So what will happen? AlCl3 is itself an electrophile because this Al is having only 6 electrons. So to complete its octet, these 2 electrons will be donated to Al. As a result, electrophile will generate and AlCl4 minus will form. Now you can see with the help of AlCl3, Cl plus is generated. In the very second step, what will happen? If we are taking benzene, here we can take chlorobenzene, bromobenzene, phenol, any sol, any reactant we can take. The reaction will take place absolutely in the similar way. Due to shifting of pi electron, because we know in benzene or in all aromatic compound, resonance takes place. It may be this carbon will be negative and this carbon will be positive, and Cl plus will attack on the benzene ring. As a result, you will see an intermediate is formed, which is known as sigma complex. After that, because this intermediate is unstable, so these two electrons of CH bond will shift in the benzene ring. As a result, once again the pi bond is formed, chlorobenzene will form along with the H+. In the third step, what will happen? In the third step, H plus and AlCl4- will react together. As a result, where the H plus is formed? In the second step. Where the AlCl4- is formed? In the first step. As a result, it will form HCl and AlCl3 will form again. If we will add these three steps, mathematically we can cancel the common ones. So here Cl plus to Cl plus cancelled, H plus to H plus cancelled, AlCl3 to AlCl3 cancelled, and you will observe the same reaction which we have wrote over here. We will got the same reaction. You may see Cl2 with benzene converting into chlorobenzene and HCl. In this way, we can write all kind of mechanism. The only difference will be this electrophile will be different. Like we do other reactions also. Suppose we are doing bromination. What will happen in bromination? Benzene, when treated with Br2 in presence of anhydrous AlBr3. So what will happen? Bromobenzene is formed and HBr is removed. In short, we can see HBr will removed and bromobenzene is formed. Mind it, this is in short. Otherwise, what will be the first step of the mechanism? Only the first step will be different. Br2 will react with AlBr3 here and heterolytic fission will take place. As a result, AlBr4- will form and electrophile Br plus will generate. So you can see, as we have seen over here, if we will use Br plus over here, here will also be the Br, here H plus will remove and the Br will come in place of Cl. Mechanism is absolutely same, only we are changing the reactants to form the different products. If we do the methylation reaction, it is the part of alkylation. Alkylation is combined term, one term to introduce alkyl group on benzene ring. If suppose benzene is treated with chloromethane in presence of anhydrous AlCl3, then it will lose HCl. As a result, toluene is formed. Once again I will repeat, this is just for the sake of simplicity we have removed the HCl directly. Otherwise what happens? First of all, CH3Cl will react with anhydrous AlCl3. Heterolytic fission will take place. Cl- will go with AlCl3 and electrophile CH3 plus will generate which will attack on the benzene ring. One another reaction is acetylation. What happens in acetylation? With benzene, when we will take acetyl chloride, when we done the IUPAC nomenclature, this is acetyl chloride. Once again we will take anhydrous AlCl3, as it will generate the electrophile in the reaction. After that the HCl will remove and acetophenone is formed. Acetophenone will form along with HCl. The same reaction we can see in benzoylation also. What happens in benzoylation reaction? Benzene is treated with benzoyl chloride. This is benzoyl chloride. When we will remove HCl, of course, in presence of anhydrous AlCl3, it will lose HCl and the benzophenone will take place. Benzophenone will form. This is acetophenone and this is benzophenone. Now here I want to add, we need not to learn these reactions again and again, but the reaction will take place absolutely in the same way with chlorobenzene, with phenol, or with any sol, of course. Suppose here I am taking chlorobenzene and we treat it with chlorine, of course anhydrous AlCl3, with CH3Cl, with anhydrous AlCl3. For acetylation we will take acetyl chloride, and for benzoylation we will take benzoyl chloride with anhydrous AlCl3. Now you can see in all these four types of reaction we are taking anhydrous AlCl3. The purpose behind it, it will generate electrophile. On the other hand, we know chlorobenzene, due to resonance in chlorobenzene, it will have negative charge at ortho and para position in resonance hybrid due to plus R or plus M effect. Due to plus R or plus M effect, two products will form. That means one product will be ortho and another product will be para. And para product will be the major one. Due to symmetry, it will be major product. In chlorobenzene what will happen? Chloronium ion will be the electrophile and it will go at ortho and para. Para will be major always if the condition is intramolecular hydrogen bonding should not take place. So here is no possibility of intramolecular hydrogen bonding in Friedal craft anytime. So always the para will be the major one. With CH3Cl, the CH3 group will come at ortho and para. In acetylation, acetyl group will come at ortho and para. In benzoylation, of course, the same way, the benzoyl group will come at ortho and para. Benzoyl group will come at ortho and para. The same kind of reaction you can observe with phenol and anisole also. If you will see, with the phenol, if you will do chlorination or bromination with anhydrous AlCl3, two products will obtain. Once the Cl will go to ortho, and in another one the Cl will go to the para. With CS3Cl and anhydrous AlCl3, the CS3 group will go to ortho and para. Here I want to add, this is cresol. When the benzene ring have OH and CS3 both groups together, that is ortho and para, or that is cresol. The other reaction of phenol is, if you will do the acetylation with acetyl chloride in presence of anhydrous AlCl3, the acetyl group will go at ortho and para. Ortho and para product will obtain. In benzylation, of course, in benzylation you have to take benzoyl chloride with anhydrous AlCl3 and you will have the ortho and para product. You can write C6H5 or you can write the phenyl ring in this ring form also. Both are absolutely same. This phenyl or this benzene, that is absolutely same. Here I want to add, for example, if you are not taking or if you are not writing the anhydrous AlCl3, by mistake you forgot to write, that means now the ortho para compound will not form. Here, in absence of AlCl3, it will lose HCl and a kind of ester will form. Mind it. You can see how important role is played by anhydrous AlCl3. In absence of anhydrous AlCl3, the ester will form. The name will be phenyl ethanoate will form. In the similar way, if you are not taking anhydrous AlCl3 with CS3Cl, then once again you will see HCl will removed and anisole will form. On the other hand, if you were taking CS3Cl and anhydrous AlCl3, ortho para product were obtained. But in absence of anhydrous AlCl3, it will give ether. With acetyl chloride, we will have ester. Now, with anisole also, you may do practice. The same kind of product will form. Anisole or phenitol, we can take any one of ether to understand the Friedal craft of ether reaction, ethers. This is phenitol, mind it. The IUPAC name may be methoxybenzene of anisole and ethoxybenzene of phenitol. If you will write Friedal craft reaction, chlorination, methylation, acetylation, and of course in the last but not least, the benzylation. The product form will be absolutely in the same way of phenol, because in phenol also the plus R effect will take place, and in anisole itself the plus R effect will take place and ortho para product will form. you can see the ortho-para product will form. Here also the electrophile will be CH3 plus. So CH3 plus will go at ortho and para. Here in the acetylation also the acetyl group will come at ortho and para, and with benzoyl also the ortho and para products will form. Here we can write any one mechanism in the same way which we have done with benzene and chlorine reaction. I can take one example over here. Suppose it is asked to us write the mechanism of phenol and acetyl chloride. What will happen in the first step? This is acetyl chloride, and when you will react with it with anhydrous AlCl3, because AlCl3 itself an electrophile, so heterolytic fission will take place. Air will try to get the stability. As a result, acetyl carbocation will form along with AlCl4 minus. In the very first step, the electrophile has been formed, and when we will use phenol, suppose we are using phenol, and due to resonance this will be negative carbon, this will be positive carbon, and acetyl carbocation will attack on negative carbon. As a result, an intermediate is formed which will call the sigma complex. This is sigma complex. This will be unstable. To get the stability, CH bond electron will shift in the benzene ring, and as a result the ortho product will form. The name of this compound may be, this is acetophenone, and we can write orthohydroxy acetophenone will form. And in the third step, as usual as we have done earlier, the AlCl4 minus of first step and H plus of second step will react together and they will form HCl and AlCl3. In this way, we can write the mechanism of acetylation of phenol. Do the practice of these reactions and learn them.